So this is our PRML group project. These are our team members Yash, Sunny, Nidish, Gaurav and Chandramouli. So in our introduction, the problem statement was of stroke prediction. So stroke is the second leading cause of death globally. It is responsible for approximately 11% of total death. So in our data set that it is was given that a patient is likely if it's facing stroke, so it will follow different parameters like gender, age, various diseases and smoking status, yes or no. So we have evaluated by using different ML techniques with various parameters and recorded the observation in order to judge which technique is more effective and which is not. So we have implemented KNN. So KNN is an instance-based learning method where no explicit training occurs. When a prediction is needed, it calculates the distance to all training points and select the K closest ones to vote for the label. Its simplicity makes it easy to understand and implement. However, it's sensitive to the curse of dimensionality and becomes slow with large dataset due to real-time distance calculation. Next, we have implemented a naive Bayes. So naive Bayes basically it is a classifier that estimates the probability of a class based on the individual probabilities of features, assuming they are all independent. Despite this unrealistic assumption, it often performs surprisingly well, especially in text classification. It's computationally efficient and handles large feature spaces, but its accuracy drops if features are highly correlated. So then we have also implemented logistic regression. So in logistic regression, it uses a sigmoid function to map any real valued number into a range between 0 and 1, making it suitable for binary classification. The model is trained by optimizing a loss function through techniques like gradient descent. It's basically widely used due to its interpretability, but it struggles when data is not linearly separable. Then we have implemented through the decision tree. In decision tree, it builds a hierarchy of if else rules to make prediction, selecting splits based on metrics like Gini impurity or entropy. Their structure mirrors human decision making, making them easy to understand. However, without pruning or limiting depth, trees can memorize training data and perform poorly on new inputs. Then we have also implemented multi-layer perceptron. So in multi-layer perceptron, it consists of an input layer, one or more hidden layer, and an output layer. It uses activation function and propagation backpropagation to adjust weights and learn non-linear relationship. MLPs are powerful and flexible, but they need careful tuning and lots of data to generalize well, and they lack interpretability. Then we have used reduction techniques like LDA. LDA is both a classification algorithm and a dimension reduction technique. It finds the linear combination of features that separate the classes. It's great for pre-processing data before classification, especially when reducing features. However, its assumptions about normality and equal class variance can limit its flexibility in complex data sets. Then we have also used reduction technique like PCA. PCA is a unsupervised method that rotates the data to align with the direction of highest variance. It helps reduce dimensionality, making models faster and sometimes more accurate. However, the new features are linear combination of original ones, making it harder to interpret the result during in domain terms. So this is our stroke risk predictor. So this is our front end. So we have developed that will predict the if the person is suffering from high risk of stroke or low risk of stroke. So if the age of the person is 67 and average glucose level we have put it 229 and BMI is 37. So no hypertension and heart disease is yes. Gender male and he is sure married, so yes. Work type is private and residence type is urban and smoking status is formerly smoked. So if we will predict, so it is suffering from high risk of stroke. So if we will change the hypertension to yes, so if we will predict now, then low risk of stroke. And if the heart disease is no, then the low risk of stroke. So you can see we are changing different scenario, then it is not suffering from the low risk of stroke. So there are mainly some factors on which it is more depending.